Very good morning to one and all present. Today I am here with the second session of pair of linear equation in two variables. Today we are going to discuss cross multiplication method. दो methods हम लोग पहले डिस्कस कर चुके हैं, जिसमें पहला था हमारा एलिमिनेशन मेथड और दूसरा सब्स्टिट्यूशन मेथड. आज हम इक्वेशंस को सॉल्व करने के लिए तीसरा मेथड जो हमारे पास है क्रॉस मल्टीप्लिकेशन, वो डिस्कस करेंगे. मैंने आपको एलिमिनेशन मेथड में बताया था कि हम कोफिशिएंट्स को सेम बनाते हैं, तो आई विल बी यूजिंग एलिमिनेशन मेथड टू फाइंड दिस क्रॉस मल्टीप्लिकेशन मेथड. तो सेकेंड इक्वेशन को हम इस a1 से मल्टीप्लाई करते हैं और फर्स्ट इक्वेशन को हम a2 से मल्टीप्लाई करते हैं इन ऑर्डर टू मेक द कोफिशिएंट सेम. तो यहां हमें मिलेगा a1 a2 x प्लस a2 b1 y प्लस a2 c1 इज इक्वल्स टू 0. सेकेंड इक्वेशन हमारी चेंज होगी a1 a2 x प्लस a1 b2 y प्लस a1 c2 इज इक्वल्स टू 0. अब अगर हम इन दोनों इक्वेशंस को सब्ट्रैक्ट करते हैं, देन वी विल कैंसल आउट दिस टर्म्स ऑफ x. Here we'll be having a2 minus a2 b1 minus a1 b2 y plus a2 c1 minus a1 c2 is equals to 0. So from here you can find a2 b1 minus a1 b2 y is equals to minus a1, we can write minus a2 c1 minus a1 c2. So from here the value of y came out to be, if I'll take this minus inside, I'll be having a1 c2 minus a2 c1 upon a2 b1 minus a1 b2. Now I will substitute this value of y in any of the equations. So let me take the first equation, a1x plus b1y plus c1 is equal to 0. तो यहां आपको मिलेगा a1x plus b1, in place of y I will substitute this value a1 c2 minus a2 c1 upon a2 b1 minus a1 b2 plus c1 is equal to 0. So a1x plus b1 a1 c2 minus b1 a2 c1 upon a2 b1 minus a1 b2 plus c1 is equals to 0. From here we have a1x is equals to, if I'll shift everything on the right hand side, I'll be having minus c1 minus b1 a1 c2 minus b1 a2 c1 upon a2 b1 minus a1 b2. So a1x is equals to, we have minus a2 b1 c1 plus a1 b2 c1 minus b1 a1 c2 and plus b1 a2 c1 upon, we have a2 b1 minus a1 b2. So here if you can see a1 b2 c1, a2 b1 c1. So we have a2 b1 c1. a2 b1 c1 positive, a2 b1 c1 negative. They will cancel it out. Then we have a1x is equals to, in these two terms your a1 is common, so you can take a1 common and you'll be left with b2 c1 minus b1 c2 upon a2 b1 minus a1 b2. So this A1 will cancel out and you get the value of x as, the value of x came out to be B2 C1 minus B1 C2 upon A2 B1 minus A1 B2. So this is the value of x and this is the value of y that we have found using your elimination method. Now how can we derive a cross multiplication from this particular these particular values of x and y? Let's, the values of x and y we have got using the elimination method. Now let me tell you, I can write the situation like this: x upon, what I'll do, I'll bring this in the denominator of x. So x upon B2 C1 minus B1 C2. What I have done, I have written it like this: x upon 1. So this will go in the denominator and I'll be having something 1 upon A2 B1 minus A1 B2. In the same way, here also if I'll be writing y upon 1, so this will come in the denominator and I'll be having 1 upon A2 B1 A1 B2. So I can write it like this: y upon A1 C2 minus A2 C1. I hope you have understood this. What I have done, I have written it x upon 1. This numerator, using the cross multiplication, I can write it in the denominator. So on the right hand side, I will be having 1 upon A2 B1 A1 B2. In the same way, if I will bring this over here, I will be having 1 upon A2 B1 minus A1 B2. That means x upon this and y upon this, it is equals to 1 upon A2 B1 minus A1 B2. So my situation changes to x upon B2 C1 minus B1 C2 is equals to y upon A1 C2 minus A2 C1 is equals to 1 upon A2 B1 minus A1 B2. अब यहाँ कंफ्यूज होने की जरूरत नहीं है, ये हमने सिर्फ एक टेक्निकली थोड़ा सा चेंज करके हमने इसको इस फॉर्मेशन में लिख लिया. नाउ व्हाट वी कैन डू, हमारे पास ये सिस्टम ऑफ इक्वेशंस है. इन सिस्टम ऑफ इक्वेशंस से हाउ वी कैन रीच एट दिस पर्टिकुलर पार्ट, लेट मी टेल यू. x is equals to y and then is equals to constant की जगह we will take 1 because this equation contains 3 parts. First one is your x, second one is y, and the third one are these constants. So for constants I have taken 1. Now when I'll write the denominator of x, what I'll do, I'll just hide this x and the remaining coefficients I'll be writing b1 b2 and c1 c2. Now when I'll be writing y, I'll be hiding the coefficients of terms of y and then writing the coefficients. I'll be having c1 c2 and then a1 a2. And when I'll be writing this constant, so I'll hide the constants and in the cyclic order I'll move and I'll write the coefficients a1 a2 b1 b2. Now using the cross multiplication technique, I can write I'll multiply it from left to right. So I'll be having b1 c2 minus b2 c1. In the same way here I'll have y c1 a2 minus c2 a1. And here I'll be having 1 upon a1 b2 minus a2 b1. Now what we'll have, we have this b1 c2 minus b2 c1 is equals to 1 upon a1 b2 minus a2 b1. So we will get x is equals to b1 c2 minus b2 c1 upon a1 b2 minus a2 b1. Now here if I'll take negative common in the numerator, I'll have b2 c1 minus b1 c2, and if I'll take negative common from the denominator, I'll be having a2 b1 minus a1 b2. These will cancel out each other, and the value of x came out to be b2c1 minus b1c2, b2c1 minus b1c2, and in the denominator I have a2b1 minus a1b2. Means it is very much similar to what I have got using elimination. In the same way you can find the value of y also. I have y is equals to c1a2 minus c2a1 a1b2 minus a2b1. If you take minus common from numerator denominator, the value of y came out to be what we have done earlier using the elimination method. So you have to remember this particular part, that we have to write the denominator of x by hiding x, writing the coefficients b1, b2, c1, c2. Then in denominator of y, hiding the coefficients of y, and then we have in the cyclic order we'll move c1, c2 and then a1, a2, and at the end we will hide this constants and we'll be having a1, a2, b1, b2. Using cross multiplication method we will solve this problem. So we'll write x upon, so when I'm writing the denominator of x, I'll hide these coefficients, the terms of x. The coefficients I have is 1, 4 and minus 35 and minus 65 is equals to y upon, I'll hide this, I'll be having minus 35 minus 65 and then 2, 3. And for the constant, I'll be having 2, 3, 1, 4. Now I can write x upon, you have to remember this, first of all this part, minus 65 and then minus in the formula, and this minus 35 into 4 is minus 140 is equals to y upon minus 35 into 3, that is minus 105, then minus in the formula, and 65 2s are minus 130 is equals to 1 upon 8 minus 3. So next what we have, x upon, we have minus 65 plus 140 is equals to y upon minus 105 plus 130 is equals to 1 upon 5. So from here x upon, you'll be having 75 is equals to y upon, we'll be having 25 and this is 1 upon 5. So x upon 75 is equals to 1 upon 5 and y upon 25 is equals to 1 upon 5. So the value of x came out to be 75 upon 5, which is equals to 15, and value of y came out to be 25 upon 5, which is equals to 5. Fine. So this is your cross multiplication to solve pair of linear equations in two variables. Another example we have, we can solve these two equations using cross multiplication method. So first of all, we can write the system of equation as ax plus by minus a minus b and bx minus ay minus a plus b is equals to 0. Now we can write the coefficients x upon, while writing the denominator of x will hide x. Now what we have, b minus a and minus a minus b and minus a plus b. On the coefficients of y, we will hide this and then we'll move on minus a minus b and then minus a plus b. And then we have a, b. For the constant we have, we'll hide this, then we have a, b and b minus a. Now we will multiply like this. First, so x upon, will be having negative b, a plus b, and negative a minus b. See, this negative I have in the formula only, and this minus will become positive. In the same way I can write for y also. First of all, this minus b, a minus b, and then this minus, and the minus of the formula will give me positive a into a plus b. For the constant 1, I have minus a square and minus b square. So let us multiply x upon minus ab plus b square minus a square, sorry, it is minus b square, minus a square, and then plus ab. So this ab will cancel out. Similarly, y upon minus ab plus b square plus a square and plus ab. Here also ab will cancel out. Now we have 1 upon, I'll take negative common, a square plus b square. So what do you have now? X upon negative common b square plus a square is equals to y upon a square plus b square is equals to 1 upon negative of a square plus b square. Now we can take two equations from here. X upon negative of b square plus a square is equals to 1 upon negative of a square plus b square, and y upon a square plus b square is equals to 1 upon negative of a square plus b square. So from here the value of x came out to be minus b square plus a square by minus a square plus b square. You'll cancel out everything, you'll get 1, and from here the value of y came out to be a square plus b square upon negative a square plus b square. This will cancel it out and you'll get minus 1. So the value of x is 1 and the value of y is minus 1. So in this way you can solve a lot of questions using cross multiplication method, and there you will be having simple calculations only. The only thing you need to keep in mind while writing the denominator of x, you will hide the coefficient x term and then write the coefficients of y and the constant. While writing the coefficient of y, you will denominator of y, you will hide the y and then you will write the coefficients, and during constant you will write first of all x, then y. And second thing you have to keep in mind, initially try to change the equation in standard form, ax plus by plus c is equals to 0. Thank you.